When dividing exponents, we have a rule that says a number raised to a power divided by that same number raised to a different power gives you a quotient where all you have to do is subtract the two exponents. So all I did was I subtracted the exponent from the bottom, so the n, from the exponent on the top. In order to explore this, I'm just going to give you a couple of examples. Say we have 5 cubed. Let's not do 5 cubed. Let's do 5 to the 10th power divided by 5 cubed. In order to get our quotient, all we have to do is take the 10 and take the 3 and subtract them. So 10 minus 3 is 7. Let's do another one. Let's do 2 to the 10th power divided by 2 to the 5th power. All we have to do is subtract our exponents. So our 10 and our 5, we subtract them, we get 5. That's our quotient. It's the same thing if we were to do this with variables. So we'll take x to the 7th power divided by x squared. Our quotient is still x, and then we subtract our exponents. So 7 minus 2 is 5. If you're wondering why this works, we'll go ahead and we'll take a look at the expanded form of two of them. So we'll do 5 to the 10th power. If you expand that, is 5 times itself 10 times. So that's 3, 4, 5, 6, 7, 8, 9, 10. So that's the expanded form of the numerator. The denominator is the same thing, but instead of 10, because it's 5 cubed, we'll just do 3 of them. So 5 times 5 times 5. And then from there, what you can do is just cross out what's on both the top and the bottom. So there's 5 on the top and the bottom. There's a second one, and there's a third one. So our solution is just how many 5s we have up here on the top. So there are 7 of them, so we have 5 to the 7th power. We can do the same thing with our x to the 7th over x squared. So we have 7 x's on the top, 3, 4, 5, 6, 7, divided by x squared. And then once again, if it's on the top and the bottom, you cross it out. And then our quotient is just how many x's are left. So there's 5 left, so it's x to the 5th power. And you'll notice that in both of these, our solution is the same, whether we do expanded form or we do the exponent rule. The beauty of this is as the problems get harder, it's a lot faster than it would be writing out the expanded form. So let's take a look. We'll make this one step harder. Instead of having things with no coefficient like these, we'll do some examples where we have coefficients. It's really the exact same process. The only difference is now we have to account for these coefficients at the front. All we have to do is simplify it. So 8 divided by 4 is 2. So we just divide those out. And then we still follow our exponent rule. So x to the 10th power divided by x to the 6th power is x to the 4th power, because all we're doing is subtracting. Same thing with our next example. We'll have 27 divided by 9, which is 3. And then we'd use our exponent rule. And anytime you don't have an exponent, there's a little invisible 1 there. So y cubed and y to the 1st power, 3 minus 1 is 2. So that's our solution. And that's all we're really doing for any of these problems. You divide the coefficients, subtract the exponents. What happens, though, when our coefficients aren't divisible by the same number or give you a decimal? If we look at this first example, 7 and 21, they're both divisible by 7, but because the 7 is on the top, dividing those out would give you a decimal. So instead, what we're going to do is we're just going to simplify. So if we have 7 over 21, both of those numbers are divisible by 7. So what we're going to do is we're just going to simplify it. 7 divided by 7 is 1, and 21 divided by 7 is 3. So in our solution, we have 1/3. And then we do the same thing where we subtract our exponents. 13 minus 4 is 9. So what we do is we don't really need that 1 there, so we would just have h to the 9th over 3. And that's our solution. We can do the same thing with the next one. If we have 18 over 12, both of those numbers are divisible by 6, and it gives you 3 over 2. So in our solution, we have 3 over 2, and then we subtract our exponents. 6 minus 3 is 3, so w cubed. And it's that easy. So essentially what we're doing is we're just simplifying the coefficients and then subtracting the exponents. So it's still the same thing as what we did back here. It's just that we no longer can divide them out evenly, so we simplify them into their smallest fraction form. Hopefully you found this helpful, and going forward, this is something that I hope you have no trouble at all with.